Ladies and gentlemen, how are we this fine evening? Welcome to another episode of What Junk Have I Bought Today? On the bench we got a regulated DC power supply by Kikusui Electronics Corp. If you remember, or if you've looked back in my in the video history, you'll see that I rebuilt a tube oscilloscope. That was the same brand, a much earlier piece of equipment. But yeah, they're a Japanese brand. They make some good stuff. So I saw this secondhand and I thought I'd pick it up because this is a model PAB 32-3, which is a 32 volt 3 amp. So it's kind of a useful voltage. I often need 24 volts or so, you know, for LED strings or whatever, just for 24 volt use. And my other two power supplies are only going up to 18 volts. So this will be a nice addition to my bench. I'm going to rebuild this thing. A few different things I'm going to do. I'm going to, number one is add a new power cord, because as with the other two that I rebuilt, also in an earlier video, it's only got a 2-pin plug, no earth, so we're going to repair that or rectify that with a proper earthed plug, a new power cord. Also on the front, old crusty banana jacks. We'll replace those with some new gold plated ones, just because gold is better. And you know, these are probably, I don't know how old this thing is, 30 years old, 25 years old or something, so they'll be a bit worn out and a bit gungy. So new banana jacks are cheap, so let's put them in, no worries. And I've got some new capacitors for on the power supply board. There are some really big chunky ones there which I'm going to have to source, but I've got some of the smaller ones here ready to go in, so I'll double check what I need, and when I come to it we'll get those replaced. The other thing I'm going to do is on the front panel here, got a nice big open area over here and no digital readout. So we've only got the analog gauges here, which are okay to see like changes in voltages, but not so good for precision work. So it's a pain just to get my multimeter out every time and plug it in and check the voltage. So I went and got these things from eBay. These are 5-digit current meter. You can see there on the back we've got the current shunt and a voltmeter. These run up to, they measure up to 33 volts, which is perfect because this goes up to 32 volts. So I'm going to be using its full range, using their full capabilities. And I'm going to put one there and the other one, oh, if I can get this unplugged, around about there somewhere. So we're going to have voltage and current as a digital readout. I think that would work quite well. New banana jacks, new capacitors, new cable on out the back, and we should be good to go. So first up, let's pull it open, see what we got inside. Okay, so there's the inside. We've got a big stonking transformer right in the middle there. You can see the vents in the bottom. If I turn that over, there you go. So the airflow can flow nice and freely through the bottom and out the top. You've got the bigger heat sinks on the back there. So there's our bridge rectifier sitting just there. We've got 3 drive transistors on this side and 3 on that side. So we've got 6 transistors all up. Good amount of current capacity there. Filter caps on the top. Nice big capacitors with their 85 degrees. I can't read what they are at the moment, but they are, what's the brand there? Marcon brand. Never heard of those ones. This is the board we're going to play with because that's got the electrolytic capacitors on it, which I'll replace just as a matter of course. This side doesn't seem to have any. I'm not sure what that board is exactly. It's got a relay, a few power transistors down the bottom there. Looks like a calibration pot on the top, and a relay there. So that might be switch and output for some purpose. There's quite a few wires coming out of it. That might be a drive for these transistors here. And these, oh, you might be driving these transistors. And then you got the power supply board for the actual unit itself and doing some other stuff. There doesn't look like there is any op amps. It's all transistor based. I can't see any op amps in there at all. There's quite a few little pots. 1, 2, 3, 4 and 5. They're actually labelled VM cal, AM cal, IO cal, EO cal, and TV adjust. So cal means calibration. So VM, voltmeter calibration, AM, amp meter calibration, IO, input-output calibration. These can actually be connected to a second unit. You can run them in parallel or series, depending if you want double the voltage or double the current through that plug there. You just plug the two plugs together, and you wire the front terminals together in a certain way, parallel or series. So that may be to calibrate that. EO, I don't know what EO is going to be, but maybe IO and EO are somehow related. And we got TV adjust, so I don't know what TV is either, because it's nothing to do with television. But then we got this TV adjust. TV adjust is here as well. So maybe it's to balance the two banks. I'm not sure. I'm going to have to see if I can find a service manual for this. Kikusui generally are pretty good about keeping manuals available for their old equipment. I was actually able to find the manuals for the old tube oscilloscope that I did earlier, which was quite surprising from their website. Quite surprising and quite welcome. So anyway, let's pull this board out and see how far we can get it out without having to desolder anything, which might not be too far. But we might be able to just lift it out slightly. What have we got? We got a screw there. Try and group these screws somewhat loosely so that I can get them in the right way again. 2 screws, and there's a third one just there. I think that's it. And will it open up? Oh yes, perfect. I like nice design like that. See, they got the wires. Oh, it's all laced. Cable lacing, nice. That's all hand done, handmade. So I like how they bring it all down the bottom so you can just, that's for servicing. That's exactly why they did that. So we got 1, 2, 3, 4 and 5 and 6 electrolytic capacitors. So what do we got here? What's this one? That's a 470 and that's 50 volts. I wonder if that's what I've got here. No, that's 1000. So I don't have them on hand, so I have to go and grab some. What is that one there? That is a 47 microfarad at 25 volts, and we have, what's that, 50 volt, oh I can't read it, 10 microfarad, and these big chunky ones at the top, 220 microfarad, 63 volt. So I'm going to make a list and we'll get new ones to put in here. But in the meantime, we might have a look at putting these things in the front panel, because I don't really need any extra parts for that. So I can do it right now. It's a bit late to head to Akihabara today to grab the capacitors. Oh, we've got 2 capacitors here as well, across the output terminals for, I guess, ripple filtering or something. There are axial capacitors, which I still can get. 10 microfarad and a 470 microfarad. So I'll have to add those to the list as well. So it looks like we got a nice big open area here. For the current meter, it has a shunt. So that there is going to have to go in series with the output terminal. So everything going to the output terminal is going to have to come to here first, come out of there to the terminal. So that won't be too much of a problem. And then the voltmeter, which uses this one, will just go straight across the terminals. Easy peasy. And then we'll have to pull a power supply from somewhere for both of them, because they both operate from 3.5 to 30 volts. So I want to take a power supply from somewhere else in here. That way they're not being powered by the output, because if the output drops below 3.5 volts, these will turn off. So that means they're going to be useless below 3.5 volts, whereas this can go right down to 0 volt output. So I want to make sure these operate over their full range. So I have to find a stable voltage somewhere in here to jack these power supplies from, or the power supplies for these gauges from. But in the meantime, maybe we can start cutting and making a mess of things. What I think I'm going to do, what I'm going to do, I'm going to actually remove everything from here. That way I'm not going to damage anything when I'm trying to cut holes. Oh, another little capacitor there too. 47 microfarad, 50 volt. 1, 2, 3, 4, 5, 6, 7, 8, 9 capacitors so far I found. Keep finding the things everywhere. So I'll pull everything out of here. I'll be back in a sec, ready to mark this thing up and get some holes cut. So I've got the front face here, all ready to go. We've got the 2 gauges, or the 2 displays. I reckon I'm going to put one about there for the volt, kind of lined up with the bottom of the volt dial, and one there lined up with the bottom of the current dial. I reckon that'll look alright, 1 and 2. So what I'm going to do, grab the old calipers, see how big we've got to cut the hole. About 45 mil by 26 mil should do it. 40, maybe 46, just 45 and a half, but 46 I reckon by 26, 46 by 26, that'll do it. Now what I'm going to do, get my tape, I'm going to mark this up with masking tape, because that way I don't have to put lines all on the panel and potentially mess things up and end up with lines I can't properly erase. So if I put one about there, I should measure this. Otherwise I'm going to get it wrong and it'll be all skewed. So that looks like we want to be about there, 51 to 53. So if I put that at 53, and then there's 53. Right about there. That should be straight. What's that say in the middle? 53. Yeah, 53, close enough. So there's the bottom of our voltmeter. The bottom of the 4 mil. Bottom of the current meter should be 4 mil from the hole. Right about there. I need a bit more room on my desk. So that comes to 103. So down here, 103 is right there. So that wants to go to there. Is that right? 103. What's it say in the middle? 103. What's it say up here? 103. That looks relatively straight. I hope. I think. Maybe. Good enough. There's our holes. That one and that one. That's where they're going to slot in. I reckon they'll fit quite nicely. 1 and 2. Put a bit of hot snot, bit of the old hot glue on the back. Once they're pushed in, they got these tabs on the side that will lock them in. But we'll put a bit of hot snot on there just to make sure they're solid. Next step, get the old drill out, and I've got a nibbling tool. You can see the little piece goes in and out. It's got like a notch in it. That means I can cut square holes, and it's just big enough to do what I want it to do. So if I cut a hole, I can stick that through and then all the way around and make a nice square hole. It's going to be a bit hard for me to do that on camera, but I'll try and show you a little bit of it at least. But some of it I'm going to be all over the place, so see how we go anyway. Now you can see here I've got one hole cut out. I've got the other one on the way using the nibbling tool. This is a pretty thick aluminium It's the maximum thickness that can fit in the nibbling tool. Is that 2 mm thick? It's a pretty hard on the hand. I mean, if you're a warm-blooded male teenager, you've probably got a pretty good grip strength going on, so it might not be so difficult. But yeah, I'm going to have to push this against my leg and you get some real leverage to cut this stuff. But it is cutting really well. I've given this one a little bit of a tickle with the file here, and it's fitting in there just nice. Where are we? Look at that. Fits in there just perfectly, like a finger in a bum, that is. Look at that. So that's going to come out pretty nice. So I'll continue with that. Whoop, I'll continue with this one. Once it's done, we'll slot them in and see what they look like. Okay, got the holes cut, nice and square. Hopefully it's looking pretty good. Let's peel it off and see what we've come up with. Nice. Huey Lewis will be proud of that. Nice. Alright, so I've got to get these the right way up. That should just kind of slot in. Oh, that's good. And that one goes in that way as well. Yeah. Look at that. Perfect. Oh, I'm happy with that. A little bit of hot glue, bit of hot snot on the back there just to hold them steady. A little bit of wiggle room there. That's not a problem because that will let us adjust it just to be spot on. Around about there like that. Yeah. Yes. So, next step I think is I'm going to put the front binding post. Now I've got the red and the black, but I need the ground. And I think I might use a green one if I can get green, or on the other power supplies I've got here, I've got blue because I couldn't get green. I think I might have one, but if not, I'm going to have to go and get one. The hole's a bit bigger than what the new ones are, but that's not going to be too much of a problem, I don't think. Hopefully. I'll just... yeah, it won't be too much of a problem. I'll just tighten it down nice and tight. The trick here is when the hole is slightly too big, trying to get the thing centered right. Alright, positive and negative, I did get them around the right way, which is always a bonus. Probably should have drilled out that hole in the middle first, but I'll just do these up finger tight to start with anyway, just to see how we're going. Yeah, it's going to look pretty good. Have one more in the middle, blue or green or whatever colour I can get, and once we've got those in, we can start repopulating this panel, put all the old gear back in, all the pots and stuff, and then start soldering things back up. So I have to go and get myself a couple capacitors and for the main board as well, and some knobs for these pots. Might go for some slightly larger knobs. I can get a reasonable size. If I go for bigger ones, they're just easy to turn, but it depends on how much space I got to here, to these panels, these displays I mean. So I'll go scrounge up some parts, and we'll continue just in a sec. Just got back from Akihabara, and I've got all the bits I need to finish this power supply. So I got the green binding post here for the ground. It's not gold, but that's alright, it's only the ground. The positive and negative I wanted gold for sure, because just for the better connection. More golder is more betterer. We got some crimp lugs, one that's going to go on the end there like that, and that'll contact the chassis. And I've got a smaller size to go on the end there, just so it's all nice and neat. I've got new binding posts as well, because These ones that I use here, they're a little bit too small for the hole. You can't drill a hole smaller than what it is. You can only go bigger. So I kind of like just tightened them up and got them as centered as I could. But I found these, which with these insulators on the bottom, means that maybe they'll fit in there a bit better. Because that insulator means that the hole size that's required for these is a bit larger. If they do fit, that'll be awesome, because it'll also match my other power supplies, which are sitting out of frame up here. The Tagasago brand, which I did a earlier video on quite a while ago. So that means they'll all be visually the same banana plugs, which just be a bit nicer. You know, no real consequence on the operation, just looks nice. Got the knobs here, brand new black knobs for the front panel there, and capacitors. So there's our bulk capacitance there. I upgraded from 63 volts to 100 volts. They're a little bit taller, but the same diameter. I've got the other ones here. These are all United Chemicons, KM, what are they? KMH and KMG series, whatever that is. I'm not sure. They'll just, United Chemicon's a good brand, so I just picked them up. They fit. They'll do the job. No worries. The only problem with these ones is that these are the snap-in style, not the leaded or the lead style. The spacing is just a little bit different by about 1 millimeter or so. So I'm going to have to drill the holes in the PCB a little bit bigger. So I have to offset the hole just slightly and get these things to fit. They should fit, no worries. Just got to drill the hole out. And the pad on the other side of the PCB, you can see it there. It's like really big and thick. So no problems at all, I don't think. And of course, our axial capacitors. These are Nichicon VX series. A little bit hard to find axial capacitors these days, but a few companies do make them. There's a Unicon make them, Nichicon make them, and there's another brand I can't remember. It's a European brand. The three main ones I've seen, but yeah, these are only 85 degrees, but we're not using it in a hot environment, so these will be fine. Nichicon's a good brand, so they'll last a long time anyway. And we've got the strain relief, a few different. I picked up 2 different options to see which fits the best for the power cable. So that's pretty much all we need to get this thing finished, I think. So first up, I might have a look at these binding posts. Then we can get the front panel all back together. We have to wire in the new digital gauges and then replace the capacitors on the main board. So, all right, have just a quick look at these binding posts. See what the new ones say. That was red. Oh yeah, that fits perfect. Awesome. No worries at all. That's good. That's a perfect size. Happy with that. One thing you'll notice with binding posts, you have a little hole there. What I usually do is I get an Allen key of the right size, and I'll stick it in there like that, and you can just kind of tweak it till it's vertical or horizontal or whatever. Yeah, vertical, and you can use that to hold it while you tighten up the nut on the back, and that way it's a good way to hold it so it doesn't spin as you're trying to tighten it up, and you make sure the binding post is up and down, which is a convenient position to have your wires hanging out. That's what we're going to look like. That's alright. Alright, I'll go ahead and get some things together. I won't bore you with the blow-by-blow account, but I'll show you a few highlights as I go along, as I finish each stage. Okay, so we've pretty much got the front panel all done. We've got our capacitors across the terminals there. The new terminals are in. Everything's all in place and fits just in there nicely. I've got to run the power for the 2 new gauges, the 2 panel meters. So I'll talk about that in a sec. But on the front, new knobs, new gauges looking pretty good, I reckon. That's going to work quite well, I think. Alright, so I've got the new capacitors in there. You can see the great big stonking things up the top here. I'll probably put some corking or some silicon sort of goop between these just to give them some support. And a few new ones around on the board there. I was about to change the new lead and I came across a small road bump. Can you see what it is? Sitting there right in front of you. Right there. This should be X-rated, an X-class capacitor, but it's not. It's just a standard capacitor. There's no fancy ratings on there at all. It's just 104K. K is the tolerance, 20% I think. And 104 is the capacitance. Can't remember what that is, but it's a common size, 104. Someone will put it down in the comments below. I can't think of it off the top of my head. And we've got 250 volt AC. So it is appropriate voltage, but it's not rated. That could catch on fire if something goes wrong inside. So I'm going to have to replace that with an X-class capacitor. I could use a Y-class as well. You can use a Y-class in place of an X, but you can't use an X in place of a Y. The difference is an X-class will often fail short, and by failing short it will blow the fuse to alert you to the fact that it has failed. Whereas a Y-class will always fail open. Well, in theory will fail open because a Y-class is used between the line and the chassis earth. If that fails short, it can live on the chassis, which is no good. So a Y-class always goes between live or neutral and the chassis, and they will always fail open. X-class goes between live and neutral. It goes between the two main conductors and will fail short to blow the fuse. So that's the next step. Once I get that, that's the last step actually, because I'll put the power cable now, replace that, and we can put this whole thing back together somehow. So it turns out that it's a little bit more difficult than I was thinking. Yeah, I've tried a few different things and I can't get it quite to work right when I'm pulling power off the main power board here, the main motherboard or whatever. So at the moment on the side I've got a LM317 regulator with just two resistors there, with, setting the output voltage to, I don't know what it was, about 15 volts ish, something around there anyway, and that's feeding around to the displays here. But I've tried a few different places to pull the voltage off, and it's not working very well because at the moment the only place I could find to pull a relatively stable power supply from, the power supply, a power source from, was near the output after the regulation. So if I pulled the voltage before the regulation, like before the dials on the front panel control, I'll get some sort of feedback loop and the thing would freak out and the output would be on and off, on and off. It was oscillating and all sorts of weird stuff. So I got it working post-regulation, not pre-regulation. But the problem with that is if I go down below 3 volts, the displays drop out because that's the lowest voltage I can work at. And if I turn it down to 3 volts or below, the output voltage isn't enough to run the displays to show you what the output voltage is. So it kind of is self-defeating and it's not so good. Also at the lower voltages, as you approach 3 volts, the displays dim. I'll fire it up and I'll show you what I mean, and then I'll show you how I'm going to fix it. So I got the lights turned off just so you can see the displays because they are a little bit dim at the moment. But if I turn the voltage up and down, the voltage is pretty close. So if I turn that up to what, around 25 volts, we've got 25 volts there. You can see this one. This is having a bit of a problem. If I turn the voltage down, it comes back up. Doesn't read exactly 0, but you can see it's, yeah, not so good. If I apply a load, so I've got this chunky resistor down here, comes up nice and bright, and it seems to work as it should. The current up and down, 3 amps, 1 amp. This one's a little bit dim, but it is working. But with no load, it's all over the shop. So I've figured out a way that, well, I think I've figured out a way we can fix that, and I'll just turn this back around. I will show you what I'm going to do. Okay, so for the fix, I'm going to use this little transformer. That's going to give us a completely isolated supply that's not dependent on this. So whatever's happening here, this will be separate from it, and it should mean that these displays are consistently powered and there's nothing feeding back. There's no feedback loops or any sort of oscillations happening. So I've got this little transformer. It's 100 volt to 15 volt. We've got two 15 volt windings. Each is at 0.1 amp rated. So I'm going to put those in parallel, and that will give me 15 volts at 0.2 amp, and that's more than enough to run these gauges. I measured them, and I think together they're about 0.12 amp or something. So it's not very much power draw on these things at all. So that will be not a drama, and I've got a nice little spot to put it just down here. Just sit there, and then of course I can't feed them AC because that's what's going to be coming out of the transformer. These need DC, so I designed up some little circuit boards. I got these made by JLC PCB. Usually I use Seed Studio, but I thought I'd give JLC a run for their money and see how they turned out. I've got no affiliation with either. I just thought I'd try a few different places, and yeah, they turned out quite well. Very, very simple, of course. It's just a linear power supply. We've got the input here, which is going to line up with basically line up with the transformer lugs. Then that comes over to a bridge rectifier here. Then some smoothing caps. The regulator is just a 7812, a standard linear 12 volt regulator. Nothing special there. And then a few capacitors on the output, and then our output terminal that goes to our gauges. The way I'm going to fit that in there, I've got these two standoffs. You can see here and here. There's two holes there. They're going to sit like that. 1 and 2. They'll screw down into the base. There's these gaps here, so I'll use some large washers to hold that in place. And then the PCB will sit on the top of there and hold it kind of like a little a tower or something. Just like that. All nice and neat. And that will then sit in there and power our gauges. So what I'll do, I'll solder this up, get this installed, and then we'll try it out and see what happens, see if it starts working properly. Alright, there we are. Our circuit is ready to go in. Turned out quite nice, I think. So 100 volts AC in here, and we get 12 volts DC regulated out of here. Not bad. So that's going to just screw down in there. Just like that. Or, yeah, that way around. So I'll stick that in, I'll solder these in, these wires in, and then I'll transfer the power wires from the LM317 into there, and hopefully it works. Well, this is a bit of a rigmarole, but I've got it working. I ended up having to do a bit of a fiddle around and whatnot to get the supply correct to these things, a bit of a trial and error. So we've still got our little transformer and power supply circuit here. That's only supplying the current meter, because whenever I was connecting the current meter up, it was all acting weird. Something to do with the topology of the circuit of this thing. It would freak out, some backfeed or something. So that's this current meter's got its own isolated supply with its own transformer, and that's working perfectly. The voltmeter wouldn't work on there because it seems to need to actually reference the ground of the main, like the main part of the circuit, so it can read through the yellow sense wire here. So that has to be supplied from the main power board. So what I've done is I put the voltmeter back onto the LM317 here, and that's got the two power wires coming down about 12 volts or so, coming around and up into the unit here, and then the yellow sense wire just goes straight to the positive terminal. So that's working correctly. Even the voltage all turned all the way down because this is connected in before the regulator, before the regulation and the voltage adjustment. So this is always getting its proper voltage. So even right down at 0.1 volt or whatever, the voltmeter still works. And then because the ammeter, the current meter, has its own isolated supply, it's working correctly. It's not freaking anything out, and it's been wired in so that I've taken the wires off the positive terminal. It goes through the current meter, the ammeter, and then out of the ammeter to the positive terminal there. So I've basically done it kind of like this diagram here. This is showing the voltmeter because that's the most complicated thing. We've got our full bridge rectifier, the full bridge rectifier sitting over here, coming in, comes in through the circuit, goes around a bit, there's some smoothing capacitors and whatnot. It then pops out for the negative, for the negative, through this orange one here to the negative terminal, and I've taken my negative for the voltmeter there, the green wire. For the positive, it's coming out the terminal up here, which goes through the power transistors, because these power transistors what actually do the voltage regulation. So we're pulling that positive just before the voltage regulators, or the voltage regulators, the transistors doing the voltage regulation, and that way we get a decent voltage out, and then that goes to our LM317 and regulates from about 50-ish volts down to our 12 volts. And our sense wire is connected directly to the positive terminal, because that's where we want to be sensing our voltage, right at the output terminal. So then, of course, the current meter, the ammeter, has its own separate bridge rectifier and transformer and whatnot, so it's completely isolated and it doesn't freak the circuit out. So it's now working. Finally, it works. So I'll put the front panel back on. I'll just screw it up like that. We'll put a load on this thing. I'll hook it up to the Keysight multimeter, and we'll see how accurate it is between the two units. We got analog and digital, and we'll see how they compare, and then compared to our calibrated 6.5 digit multimeter. Okay, so we're set up here. I'm using the other microphone on the camera, so it's going to sound a little bit different from before, but that's alright, we'll make it through. I've got the old Keysight up here. It's only a couple months old, so that's perfectly within calibration. We've got that connected through to the front terminals here, and then we've also got our leads coming out from the front terminals, so we can do a current test just with a bit of I think that's a 4 ohm or something, load resistor. But first of all, we'll have a look at the voltages. So we'll just turn that on and see what we're reading. So just at turn on, we're reading 13.233, 13.235, 36, settling down a little bit. But if you look at the two numbers, 3 decimal points, and it's pretty much spot on. That's actually really good. I'm actually somewhat impressed with how good these little displays are, how accurate they are. So if we go down to 10 volts, just trim that up a bit, or a little bit, there we go, a little bit too far. That'll do. 10.06, and we got, or 10.006, 10.006, perfect, it's spot on. Go to full scale, what do we got? 32.064, 066. We're basically reading the same up here as well. It's not a problem there. That's reading spot on. I think the if we go to say 20 volts, dial that in. Close enough. The gauge here is also spot on too. I can calibrate that with some dials on the side, some trim pots on the circuit board there. But that's reading real good too. So I'm going to say that's a win. Take it up a bit. Get 10 volts again. There we go. That'll do. That's spot on 10 volts there. So the analog gauge is working, and the digital gauge there for the voltage is working. So my Keysight here will read 3 amps. So if I go to DC current, and I'll just rejig these a little bit. Let's see. We want it to come out. We want it to go into there. We want it to come out of there. Whoops. I'm just hooking up to the resistor here, and then if I hook that in there, we should see how much current we're drawing. At the moment, 1.6704, 1.6, it will round up to 7, so that's pretty close. Dial that down to about 1 amp, and we're reading basically 1 amp. We're off a tiny bit, but that's pretty close. I'm not going to sneeze at that. The analog gauge there is working as well. So according to the key site, this is reading a little bit high. I think there might be a trim pot to trim that on the gauge itself, so we can play with that. I'll have a bit of a tweak of that later, but that is pretty good. I don't know how far the key site can go over 3 amps, so I'm not going to go too much further, but yeah, that's looking pretty good if you ask me. So I'm going to put the case on that thing, and I think we might be done. There we go. Not too bad. That's going to be handy being 32 volts, good for some 24 volt projects, whereas these two here, I did a video a long time ago on one of these, they go to 18 volts, so a little bit restrictive when I want to go a bit higher voltage, but that's going to be handy having that one there. So not too bad if I might say so myself. Give myself a thumbs up, and if you like the video, give me a thumbs up too, and we'll see you in the next one.